Hands up if you're ready for this last talk to be over and done with so you can get to the pub, the restaurant, to see your family, your friends. We're all done after a hard day's listening to talks.
Someone's had to clear up.
Okay, so next question. Who here has used ATT&CK? How many of you are blue? How many of you are red? Blue hands. Red hands? So this presentation is for all of you. Very much a considered view from someone who's played both sides of the fence over the last 20 years. I started in a SOC. I spent a good deal of time red teaming. I'm currently doing detection engineering for interesting customers in interesting places. But anyway, who am I? So I'm Tim. So as I said, I started life in a SOC. This was before, as a Cisco person, this was before Splunk. This was before Seams even existed. The first SOC I ever built, we used SQL Server to collect our audit data. And then we ran hunts overnight using SQL queries to get results out. Then I spent probably 15 years doing offensive stuff for critical national infrastructure. Today, I work inside of Cisco, bridging that gap for Cisco's customers. You can see there, I collect CVEs. I may have rather a few to my name, but more recently I've been collecting MITRE attack techniques. I kind of sat there and went, well, we're really not doing detection as well as we would like. How might we do it better? So previously, as I said, I've played both sides of the fence. Done an awful lot of offensive research on Unix platforms, ranging from looking at how our banking infrastructure worked at the bank I worked at in that SOC all those years ago, right through to more modern day stuff, looking at how AD integration works with Unix systems. But then on the other side of the fence, I've spent a fair bit of time consulting on how to build better SOCs. If you didn't see it, there was a great talk in the rookie track earlier from a guy called Tim. Fantastic summary of the problem space in which we all inhabit. But yeah, I spent a fair bit of time on both sides of the fence, and I would like to make sure that we remember we're all in it together. We should be one team, and if you're a red team that turns up, delivers your report, and brutally fucks off, you're not helping your customer, you're probably not helping the country, and you're certainly not keeping humans safe and secure. So the agenda, introducing Linux malware. So Linux malware was a project I started about 4 years ago, looking at how we tackle this gap between what the blue team think of the world and what the red team think of the world. I'm going to go a little into what the attack landscape looks like. For those of you that don't know, I'm one of the community representatives for MITRE, based in the UK. I am probably the UK's main representative into the MITRE attack framework. But I'm going to go into a little about what we've been doing there, how we've been helping MITRE improve attack for Linux. I'm going to talk a little bit about what that looks like from a technological perspective, because it's clearly not just a problem of we don't have the information. Sometimes it's about making sure the information ends up in the right places with the right people and they know what to do with it. Going to touch upon detection engineering, because everyone will tell you that EDRs are the only way to go. Not everyone necessarily wants to deploy an EDR to their core banking system or their packet core inside a service provider. So what else can you do? And then I'm going to wrap it up with some conclusions based on 4 years of trying to fight the good fight and make us better. So Linux malware. Linux malware is a project that attempts to categorize, qualify, and reanalyze every source of threat intelligence that exists from a Linux perspective in the public domain. We do not go back through Cisco's own stuff. This is an entirely siloed project so that we can share it with people like MITRE. But essentially, if we found a piece of offensive tooling, if we found a piece of offensive research, if we've seen a threat intelligence report from one of the MSSPs out there, if we found anything that tells us a little more about how attackers work on Linux, it gets pushed into Linux malware, and then we use that to refine MITRE attack. And when I say refine, that involves sitting down with MITRE, having long in-depth conversations, discussing what has been reported, perhaps in some cases explaining what's been reported and why it matters, giving them context around what syscall that was and why that syscall matters and which files on the file system perhaps should be being monitored. Yeah, real technical stuff about taking threat intelligence and making it useful to more people. That's how the project kind of came into being. Essentially, I was complaining that Linux mappings in ATT&CK weren't very good, and MITRE said, how about you come and help us? And I said, well, I like nothing more than that kind of problem. I'm very much a believer in helping society rather than necessarily commercialising every piece of thought that goes through my head. So yeah, for the last 4 years, I've been building a repository that hopefully will make us better at defenders. And I think actually the statistics and the threat intelligence reporting we're seeing in the wild probably bears out the fact that actually things are improving, things are getting better. There's a timeline of some of the threats and some of the malware sources that we've seen over the last 4 or 5 years. We're certainly seeing more sophisticated attacks. Is it because there are more sophisticated attacks? I think actually it's probably because we're slightly better at spotting them. At least I like to think so. So where all of this started was, I'll build a honeypot, or I built a series of honeypots. I deployed honeypots across the globe. At one stage or other, I had a honeypot that purported to be a bank in Brazil, because they'd used an IP address in one of the VPS for their bank. Then they'd closed that particular VPS, and I'd got the IP address, and it turns out I was getting SSL connections to my honeypot with a host name that was a Brazilian bank. That was kind of quite interesting, but it was a good way of seeing what adversaries are actually doing. There's a summary on the screen. I ran 2 types of honeypot, an IBM MQ. Those of you who don't know what IBM MQ is, it's a message bus. It's a way of allowing enterprise organisations, the likes of your FTSE 100 and equivalent, to pass data around their organisation. So if you have an application that sits on the internet and you have a core banking system that sits at the back of your organisation that holds all your customers' data, chances are you're using a message bus to pass data between them. DB2, hopefully people are aware of what databases are and how they work, but essentially very similar. The idea was put 2 standard enterprise applications on the internet, leave them with some open doors and see how people get on. Do adversaries find them? Do they do interesting things? Sadly, not. I was pretty disappointed by this. I'd really hoped I was going to catch lots of interesting malware, but as you can probably imagine, most enterprises, at least the competent ones, don't necessarily leave these systems on the internet. So perhaps it's unsurprising that adversaries weren't necessarily looking for them. But it was certainly a first chance to see how people were behaving, what adversaries might do. Then we moved on to, what malware is available? And I have access to VirusTotal, but I wanted to make this repeatable. So for those of you who don't know, Malware Bazaar is run by a team in Switzerland on a non-profit basis. It's free to use. You can run your own hunts. You can upload Yarra files. You can run queries. You can do more or less what you like, and you can see the results. And a lot of malware gets pushed into it, so you get to see some really quite interesting samples. But anybody can do it. So if you're a college student and you don't have the ability to go and get a corporate VirusTotal license, Malware Bazaar is definitely somewhere you should be looking. And that's what I was really looking for. Unix malware. The really interesting stuff. Most of what goes into most of the antivirus sandboxes, the detonation engines, etc., in the way of Linux stuff is pretty dull. Dull's perhaps not the right word, but it's IoT. It's your router in your house. It's the coffee pot. It's the mobile phone, etc. That wasn't really what I was interested in, but it was again an interesting opportunity to sample what was already available. There you go. That's the kind of thing you find in Malware Bazaar. Lots of MITRE. Are you all familiar with what MITRE is? Anyone not? Care to be Hannah? So MITRE is a particular botnet that affects IoT devices. Typically, it's targeting things like PowerPC architecture, ARM, embedded systems, etc. But as you can imagine, sitting on the internet, there's an awful lot of those types of devices. So no surprise that there's an awful lot of that type of malware kicking around. But more interestingly, we can see what types of malware were being delivered, what types of distribution mechanisms were being used, whether they were compiled, whether they were Python code, etc. And it certainly gave us another view about what was happening. So I took it a little bit further. I started writing Yarra rules to go and look for things I was interested in. And you'll see up there, there's some obvious examples of things that perhaps you might understand why I'm looking for them. Cisco Tools is an interesting one. So Cisco Tools, I went and wrote a signature for all of our open source offensive tooling on the basis I'd like to know if people are using that for bad things, and you'll see why in a couple of slides' time. But essentially, I wrote a bunch of signatures. Some of those signatures matched on things. I got quite excited. Until I got sad. So it turns out, and this may be true for other sandboxes also, but particularly Malware Bazaar, it didn't actually know what AIX even was. Go back to that problem space that we had at the start. We want to understand the more interesting threat actors. We want to understand what's happening, could be impacting businesses, etc. If all the detonation tools miss the fact that there's even an AIX binary being submitted, that's probably a problem, because if we don't identify what it is, how do we effectively analyse it to work out whether it's doing bad things and whether we should be worried about it? In the case of AIX binaries, they present in a very similar way to Windows 32 binaries. So every time we got a match on our previous slide that said it was an AIX binary, turns out, with the exceptions of the ones that I uploaded, it was actually Windows binaries that it triggered on. And of course, when you start to look at it from a Unix reverse engineer's perspective, you very quickly realise that you're not looking at the exciting holy grail that you hoped you were. But anyway, the good news, the bad news. Weren't many useful matches on my hunts. I think it's been running for 4 years now, so you saw the numbers from most recently, but not as much as I would like. So that's kind of quite good. But it's not the only place that malware goes. So I went and had a look at what VirusTotal does. So this is one of our tools. I submit all of our tools to VirusTotal as a matter of course, so that I can see when they're being used, and I can see if they're being used for things that I think might be problematic. In some cases, those tools aren't necessarily things that are fully public, and so, yeah, the signatures and the detection of those tools is pretty important to us. The first line is Linux, the tool I wrote to attack AD-joined Unix systems. In its natural default state, I grabbed it from GitHub, I uploaded it, and not too bad detection. We got a reasonable success rate. The problem is, you change 1 byte, nothing now detects it, or very little detects it. Again, symptomatic of the problem. If we can't identify when it's an important binary, if we can't identify when it's a known piece of malware because of a single byte change, that's a real problem. And actually, I talked to a friend of mine who works for a financial services organisation. They've been working with one of the EDR vendors for 6 to 12 months to try and get to a point that they can detect Linux. And every time they detect it, my friend changes a byte and then runs the EDR again, and every time it misses it. Financial services organisation that's processing billions of dollars a year kind of thing. They can't detect a shell script when a byte changes. This is the problem space I'm trying to help people solve. So does it matter? So the binaries, the AIX binaries, were for fast cache. Fast cache is a piece of malware from the North Koreans, so very much people that matter. They had used that particular piece of binary to manipulate the SWIFT network into giving them loads of money. And as well you might expect, some analysts have found it, they'd had a look at it, and they'd found some interesting things. I'll come on to perhaps some more observations about fast cache in particular later, but it's as an example of a particularly high-end piece of malware that was being used by a particularly interesting threat actor. This is a really good example of the kinds of things the best red teams, let's call the North Koreans the red team, this is exactly the kind of thing that the best red teams are capable of doing, and if our organisations can't stop it, we will have serious problems. So from there, we have 3 hypotheses. 1, attackers may be using our tools. Curious to test that hypothesis at scale. 2, attack is already fine. It's already doing a good job of detection. 3, perhaps it's not. Perhaps there are some areas we can improve it. And that's pretty much the pitch I gave to MITRE was, well, okay, so can you detect the stuff I do? Can I tell you things that you're missing that I see other malware do? How do we fix this? And they said, yeah, come and help us. And that was the start of a 4-year conversation that's still ongoing and still not resolved. So, do adversaries use our tools? Certainly to some degree. We ended up adding new techniques to ATT&CK to cover some of the things that our tools were doing, specifically in the case of linux, adding mappings through to the same tools that you would find on Windows for dumping hashes, for dumping cache credentials. We went and wrote the mappings for linux for Linux and AD-joined Unix systems. The mappings there are pretty good. They perhaps weren't quite aligned to the full gamut of tools that are available, but it was a solvable problem. And from MITRE's perspective, they can only include stuff in ATT&CK that could be citable. The fact that my tool existed and they could look at it and they could see it meant we could factor that into the equation and we could improve ATT&CK in that fashion. Second question, are they using techniques to target Unix systems? Again, largely the answer is yes. The example I picked up here is another threat actor at the higher end, Hidden Cobra. And yeah, they were definitely doing things that would fit into what ATT&CK was already documenting. Perhaps not the way that ATT&CK had envisaged it being used, nation state, etc. But there were some good mappings there. And are they targeting Unix systems? Yeah, well, Light Basin targets telecoms providers. And yeah, they're using the stuff that you'll find in MITRE ATT&CK, but they're also using stuff that we've missed for decades. Like, Light Basin are using a tool that I remember seeing on Full Disclosure and Bug Track about 20 years ago. I spotted it when I saw the reporting from CrowdStrike because I recognised the strings in the file in the screenshot that was in the CrowdStrike reporting. That's the kind of thing that I wanted to be able to draw back to. It's the kind of thing I wanted to use to inform others. If we can't spot something that's being used from 2001 onwards, we've got no idea where it's been and what it's being used for. But can you imagine somebody sitting there going, well, we'll go and download a 2001 tool? No, of course not. They've been using it for ages on lots of different environments for lots of different things. We need to be able to detect that properly. Thirdly, ATT&CK is not representative. I think my answer to that would be is it wasn't. It's becoming more representative. And indeed, I shall talk a little on why and how. Any questions so far? You can throw questions up at any time. I may choose to park them to the end if they're particularly interesting and I want to expand on them, but ask questions as you go along. So yeah, that's a loose summary of what the threat landscape looks like for Unix systems. You've got the botnets that sit on IoT networks. You've got the access brokers who want to compromise embedded network devices. You've got people that are in the ransomware game, more likely, interestingly, to target the hypervisor of a Linux system necessarily than a Linux system itself. Yeah, you can see malware examples that are specifically targeting VMware, etc. You have the cloud enthusiasts. I don't know who saw Rory's presentation earlier. But Rory and Datadog very much focus on the cloud stuff, and yeah, there are definitely threat actors that are interested in borrowing your compute, borrowing your CPU, your memory, etc. Maybe because they want to mine bitcoins, maybe because they want to play around with AI, but yeah, they're out there. And then at the highest end, you have the specialists. So Light Basin, UNC 1945, the kinds of people that were in that previous reporting from CrowdStrike that are targeting very specific systems with really interesting protocols to do maximum damage quickly and get out. Either because they want to damage the infrastructure or because they want to steal the money that's on the infrastructure. So you'll see things like networks being wiped in totality. You'll see things like people targeting IBM MQ because they know that they can use that to talk to the payment platform inside a service provider, and now they can reduce their monthly bills, or worse. So we have some notable threats. This is kind of a timeline of how things have changed over time. Fast cache was my patient zero. It was the thing that got me interested in the first place in this. But more recently, we've seen GTP door. GTP door is a specific piece of malware that gets deployed into telecoms environments to target GTP, which is one of the signaling protocols for making receiving phone calls. Very high-end, very interesting stuff. But, you know, the example of XZ being compromised earlier in the year, another good example of a modern piece of malware. Interestingly, if you're a pen tester today, there was a report 2-3 weeks ago that one of the favourite pen testing tools of the UK market, linps, had been modified to have a call home. And if you grabbed the version of GitHub, you didn't get the call home. But if you grabbed the version of linps.sh, you did. We are seeing this kind of thing happen on a regular basis. And indeed, in some of the cases, we're seeing things that retrospectively we now see as looking fishy. If you look at how XZ worked at an exploit level, or rather how the payload worked, you can go back and find other examples of threat actors doing similar types of things, either with other pieces of commercial software, or indeed with other proof-of-concept exploit code that then gets run on pen testers' laptops and ends up compromising pen testers. So there's a fair amount of interesting stuff there. It's just that we're perhaps not historically great at sifting through it. So there you go. That's attack in numbers. So when I started working on attack in 2021, there were 328 techniques and about 120 or so were targeting or purported to target Linux systems. Today, there's less techniques because MITRE have been working on cleaning up their data, mapping things more effectively, looking at how two techniques could be one technique with multiple sub-techniques. So perhaps slightly less techniques, but certainly a higher preponderance of relevant techniques if you happen to operate a Linux system. And the same is true with the other aspects also. We're seeing more advances in tooling, we're seeing more advances in malware families, and that's why I say we are getting better. But if you look at the graph on the whole, you can kind of see what that looks like. Over time, MITRE attack version 1 in the left-hand side, didn't know about a huge amount. By the time you get up to kind of 11 and 12, there's an awful lot of stuff that's now properly mapped into MITRE attack. And then as MITRE have been cleaning up the data, we've seen a little bit of a crash in terms of the raw numbers between 14 and 16. But ultimately, the techniques themselves, as purported by the left-hand side, we're still seeing increased visibility and increased knowledge about the kinds of things that adversaries are doing. Well, there's my little contribution. So I said I'd started collecting techniques. Those are the ones that I've worked on personally with MITRE. So if you've got an idea for something you want to talk to MITRE about, doesn't matter if it's Linux, although clearly that's my area of interest, come and speak to me afterwards and I can facilitate some conversations with the people that might better help you get it on other people's radars. But we've got the stuff that I did around manipulation of libraries and linkers. We've got the stuff that I did around Active Directory. But we've got other things too. Break process trees is an interesting one. I speculated in a Twitter post that this might be possible. A couple of DFIR people then took it on and wrote up some really nice detailed descriptions of my tweet. We've actually found malware doing it now. So that hypothesis view of the world, that there are things that we would expect adversaries to do that they are either doing and we're not spotting, or that they haven't started doing but they could be doing, is definitely true. And that's why I wanted to get involved, to try and catch some of that stuff before it becomes prevalent. So how do we build a better attack? Would anybody here like to build a better attack? Would anybody here like to have an attack that's more relevant to their industry, to their vertical, to the systems they care about? Alright, so this is how I did it. I automated everything I possibly could do. The automation's not as good as I would like. There are shell scripts and Perl and Python. It's very much not a software developer's view of the CI/CD process. Very much a Tim's view about how can we do things quickly view of it. But we have the ability to take a URL, triage if it's a piece of malware, triage if it's a new piece of tooling from a red team, a pen test company, etc. Triage if it's a piece of threat intelligence. From that, we then have the ability to start to dynamically allocate techniques and sub-techniques based on the data that we've pulled in. So I can take all of the threat intelligence that gets published by all of the threat intelligence companies, grab the URL, drop it in, and it will give me a summary of what techniques are in there. Even if the threat intelligence company didn't put the technique in themselves, or if they've missed one. They've got a screenshot that shows a particular thing that I'm interested in. I can now see that, and I can now feed that back into MITRE. So when MITRE sit there and they go, do we have any evidence of this? And I'm like, yes. Here's the list of issues in GitHub that shows you all of the places that it's been reported either from a threat intelligence perspective, a malware perspective, or indeed an offensive researcher perspective. So, if you have no better way to do it, GitHub can work as a threat intelligence platform. For my purposes, it works quite nicely. I have templates that allow people to ingest information effectively. Worst case, they give me a URL. Best case, they give me a lot more information. I have the ability to label it up quite nicely, so I can start to see trends. I can start to see clusters of intelligence about a particular thing. And then I can put workflows on that, so I can trigger automatic triage. I can trigger analysis of that threat intelligence report, etc. It's a PDF, it's a Word document, it's a text file, etc. All of that can be automatically triaged. GitHub aren't always friendly to malware. I was very upset that they pulled the iSoon leak. For those that don't know, iSoon was a commercial entity in China that was working ostensibly as a penetration testing research company, but were probably working on behalf of the Chinese government. There was a leak of a bunch of their stuff, which is kind of quite interesting. You could see what kinds of things they were targeting. They were interested in DB2, but unfortunately GitHub decided to pull it, allegedly because of the amount of data that was in the repository, but you can only speculate that possibly from GitHub's perspective it wasn't the best thing in the world to have a whole bunch of stuff that purported to be from a state-aligned actor sitting on their GitHub that anybody could look at. But yeah, there's value in automation. So even if you don't have the ability to go and buy the biggest, flashiest tools, even if you don't have the budget to go and buy Splunk like Cisco did, you can still do quite useful things with a little bit of time, a little bit of thought, and a little bit of creativity. So there you go. That's kind of how the analysis engine that I've built works. Broadly speaking, it scores everything. It scores everything by keywords, it scores everything by the reporter. It correlates things. I can then start to say, well, actually, these three issues relate to the same thing. Show me all of the issues that relate to this thing. I'm not a data scientist. I work with data scientists, and they're helping me improve the scoring and the modelling mechanism. But what does it look like in practice? These are some of the kinds of fun things that I've been doing with it. The ability to go and clam scan everything that comes out of Malware Bazaar. The ability to run my own custom Yarrow rules outside of Malware Bazaar. Because from my perspective, maybe the stuff that I want to do that I don't necessarily want to immediately share with the rest of the community. Run things like Kappa. Do things like file analysis. Look for the kinds of indicators I would be interested in as a threat intelligence analyst, or as a responder, or as a red teamer that wants to go bad, etc. And you get to learn interesting things like this. You'd have thought that a malware operator would be writing secure code, right? I mean, they're busy taking the mick out of everyone else for not keeping their system secure. The last thing you'd expect them to do is write code that uses HTTP, that uses hard-coded credentials. No. They're just as bad as the rest of us, unfortunately. I think a few of them need a few lessons from dinners in the software development lifecycle. So this is all stuff that isn't yet in ATT&CK, that maybe should be an ATT&CK. Some of it, on the left-hand side, is kind of there just about, we're kind of getting our heads around what the problem space looks like. We're starting to understand how we want to define it from a technique perspective, how we want to scope the technique, etc. Uses Go. We capture whether it uses Python or JavaScript or PowerShell or VBS. We don't check whether it uses Go. Go is very popular with malware operators because, guess what, you can compile it anywhere and it's secure. So they've met their SDLC requirement for the year. Process tree spoofing, that one is actually now in, I think. But yeah, some of those are non-obvious. Redirection to none. If you have a Unix system and you know what's running on it, as if it's a business workload you should do, anything that writes to dev null that isn't something that you know writes to dev null should be an alarm bell to go and have a look at it. It's a really daft indicator, in the sense that, well, everything uses DevMod. Yeah, but if you know what your system runs, you know which scripts are on there. Anything that you didn't recognise or put on, probably something you should know about. So yeah, there's a whole bunch of stuff we're doing to kind of pick out things that will be interesting for future techniques, etc.
That's a question.
Yeah.
Where do you get that analysis?
That is produced inside of that. So inside of that, you have analyze articles, which does analysis, word-based analysis on threat intelligence reports. You have triage binary and binary lint, which do a very similar process across binary data. Crudely, it's a combination of strings and Yarra, for the binaries in particular. In the case of the analyze articles, it actually is just correct. This really is that dumb and simple. But essentially, yeah. So every time I see anything that has a string in it of /dev/shm or /temp, that goes into, well, they're writing to a non-persistent part of the file system. Why would you do that as an adversary? Because if it's non-persistent, when the box reboots, that file is potentially gone. May not necessarily be an indicator on its own that you've got malware, but it's certainly something that we ought to be able to track and understand, and be able to, back to that piece around understand your applications and correlate effectively. You should know what applications are writing into your temporary file systems. You probably should have some controls about which applications can, because a lot of exploits will write to those locations. But yeah, so that one's not a particularly useful indicator in isolation. But like DevNull, you put it together with other things, you now start to see behaviours that aren't common and consistent with how your applications work. So, can we do better? EDRs are fantastic if you can deploy them. You can't deploy them everywhere, because it's operational technology, because it's telecoms infrastructure, because it's a banking application, Red Hat 7.9. We can do a lot with AuditD. I talked earlier about working in that SOC at the bank using SQL Server. We wrote rules in that organisation that would allow us to mitigate an attack on Swift. We found a vulnerability during our hardening process. Yes? Better? It's because I'm standing, yes, because I'm standing on one side, but yeah. So yeah, the bank, we wrote rules to mitigate a vulnerability we found in the Swiss software we were using. There was a world writable location that anybody that had any level of access to the system could use to write to and then manipulate payment transactions across the globe. We couldn't get the Swift vendor to fix it in a timely fashion, so we wrote AuditD rules that would basically monitor those locations for anyone writing to it that we didn't expect. That's the kind of thing that AuditD can help you do. It's there in most Linuxes in a way that eBPF perhaps isn't. It doesn't require you to put an EDR platform in place. It just requires you to write a configuration file. Definitely something to explore if you're running Unix systems and you have no way of knowing what's going on them. So, as an example, we wrote a set of detections for BPF door. They are publicly available elsewhere, but essentially walking you through it, I mapped through the different parts of the attack lifecycle, what it was doing, when it was doing it, why it was doing it, which system calls were being used, which files were being accessed, and from that we could write an AuditD policy that would allow us to reliably detect BPF door's existence. This is the example from the bank. It's done with AuditD rather than the tool we used at the bank, but really trivial. Everything that's a world writable file becomes of interest to an attacker. Let's have a rule that tells us when someone writes that file. That was running on my honeypot, so I could see if anybody compromised any of the applications on the honeypot network and what they did next. So there's a crib sheet. Here's some things you need to know if you're using AuditD. Not everything gets logged as easily as you would like. There are some places where you need to recognize the limitations of the technology. Also true for eBPF, but for example, once you've got a kernel exploit running, all bets are sadly off. If you've got the ability to rewrite kernel memory, then, well, yeah, anything that happens post that point If you talk to the EBBF people, they'll tell you very clearly, capture the events on the way in, don't wait for the system call to terminate. Good advice, similar can be applied to Audit D. But yeah, there is detection capabilities we could be using today that we're probably not. And with that, some conclusions. Hypothesis 1, adversaries are using the tooling that I've written. Not anywhere near as much as I was worried about. And in fact, the Yarrow rules that triggered on Malware Bazaar weren't actually for the tools I was hoping to find triggers on. They were actually for a PHP socket that would serve up a shell. But yeah, we've seen examples of people using our tools. In terms of attacks techniques, yeah, they are. They're using the techniques that MITRE are describing, and we're seeing them using them in any ever more creative ways. Can an attack be more representative? Yes, it absolutely can be, and that's the purpose of my mission with MITRE, is to try and make that happen. But we've helped other people too, right? So there are Linux distributions that are now taking on board the work and using it. In fact, the paper that I've linked to there was a piece of work done by ChainGuard. We're a cloud-native distribution vendor. And they've essentially taken on Linux-malware as one of their seed sources for all of their detection engineering capability, because they recognise that it's a single source of malcontent, should we say. Not necessarily malware, because sometimes it's pen testers' tools, but it's a good place to be looking if you want to be able to test your detection capabilities effectively. Just because attackers aren't being reported breaking into systems daily doesn't mean they actually aren't. Adversaries will still use the most simple mechanism they possibly can do, which to you and I, in many cases, is passwords. The number of Unix systems that I audit each year that still have default passwords of one form or another on them, that would be an obvious place to start. If you're doing adversary simulations, I would argue that Linux malware is probably as good a place to go to collect the information you need to start that adventure. And if you're a defender, I'd argue it's probably as good a place as any to start if you want to understand what you should be defending from and what that attack might look like. We can do better, and indeed MITRE have acknowledged that. They are now spinning up a working group to do similar things to Linux on networking devices. So if you have an interest in routers and switches, I might do, you can go along and have conversations about that also. There's a separate Slack space specifically for network devices, and they are looking to refresh the way that they map the techniques there. I'd like to think it was going to happen anyway, but I did complain to them about that. I put my mouth up where it probably shouldn't yet again. But yeah, come and help, come and pitch in. I'd love to see the UK market be far more responsive and contributory to what MITRE are doing. It's a mission that everybody should be able to get behind. Unlike most of the stuff you see from cybersecurity companies, Cisco included, there's a commercial requirement. Buy our EDR, buy our firewall, buy our detection capability, buy our SOC. MITRE, none of that. Just a bunch of really good, helpful people who are trying to make the world a little bit a better place. So that's the pitch on MITRE. And there you go. If you cannot detect anything else, these 5 rules would be things I think would be a good starting point. The ability to detect whether someone SSHs onto your box, the ability to see when they're running privileged processes, the ability to see when they're running a raw socket, so pretty much GTP door, the fast cache stuff, pretty much most of the high-end malware will create a raw socket as part of that attack. So that's a good one to go and detect. The ability to write to non-persistent file storage. It's pretty common that malware is going to drop its malware somewhere that it can do. That's generally temp or dev/hm. And modifications to the 2 key sources of persistence, cron and the runtime linker. Detect those 5 things and you'll probably catch 99% of malware today in one form or another. Even the stuff that got published just last week. Those 5 things probably would have caught it. And with that, far too many people to thank, and there are names that I couldn't put on there for various reasons, but there are an awful lot of people that are working with me now on this, and some of those people deserve a bit of thanks for the work they've put in, not least of which the MITRE crew themselves, who've been very open and receptive to my ideas, and been willing to listen and work with me rather than sit there and go, well, we know better. That is about it. So questions? Or do we shut the fuck up and go to the pub? Yes.
I don't mean like this is a joke question. How did you get them to standardize your email on your middle name?
Sorry?
Your Cisco email address. How did you get them to standardize on your middle name?
Oh. Why is it the block? How did I get that name?
No, it's a joke.
Can you speak into the microphone for the record?
Sorry? Back up. So I think I understood the question. I was a bit confused by it, but yeah, Wadhwa is my wife's name.
I think he was asking, how did you get Cisco to not give you a standard dot?
Oh, I see.
Email.
Ah, right. Well, that's just Cisco's format. It's a lucky number generator, basically. You can go and ask for usernames. I may have played around with that a little bit in the past, but that's a different story for a different audience, I think. Any?
Linux logins or whatever you want to call
Yeah.
it, equivalent of it, like whenever I got talked to pen testers about loads of getting internet systems, log has been like log interface. So what I assume you just make monitoring reports, or anything you can comment on log things, or because that seems to be
So the question was, what happens with log bins? And in Linux land, we call that GTFO bins. There's a separate project for GTFO bins for Linux, and it's essentially a list of commands that have alternate uses. So the most trivial example of that would be something like find, where you can run a find command and then execute something based on the output of the find query. And you might use that to go and find files that you should have. 2 minutes left. You might go and use that to look for files that, because you're a sysadmin, but you might also use it to trigger execution because you've got the ability to control part of the parameters. We've mapped some of that. But I don't think we've done as good a job as we might, is the short answer, I think. So there's more work to be done there.
Just a quick one on the classification.
Yeah.
Is there a taxonomy and doing sort of like graph that you can try to use to arrive at those mappings? Or I mean, even like when you process those PDFs or that data that you get, do you find that sometimes that already is already there, or that
There is no perfect taxonomy. It's like compression, right? You're essentially reducing a massive namespace down to a smaller namespace, and you're going to potentially lose information along the way. The taxonomy that I have is probably as good as I've found for the stuff that's not known about. For the stuff that is known about, MITRE's various different sources of information, be that ATT&CK or CWE or whatever else, they're probably the best taxonomies that are available. Vendors might tell you otherwise.
This is a real question. On one of your other slides, you listed EDR vendors with the EDR
Glenn, I can't hear you. Can you shout?
Yeah. 14 vulnerabilities in EDR.
Yes.
You've been watching it for a while, trending up or down.
Well, it will have gone up.
So, like, are they addressing it at all, or are we walking into?
Oh, I see. What do we think? Do I think it's linear, or do I think it's going to escalate? They're doing a pretty good job of squashing the places that they know they've got problems. It's lucky it's been modern. It's modern engineering, and it's been built by a team that are security savvy and security conscious. So I don't think we're going to see that, but I do suspect over time we'll see a continued trickle as new pieces of code get introduced, because inevitably when you write code you introduce bugs.
Considering that you guys are collecting, extracting, scraping so much data,
Yeah.
I was wondering whether you happen to have any publicly available data sets that InfoSec academics could potentially conduct studies on.
Go back far enough. That's all public. There's a huge data set, it's all public. And every open source project that we find in GitHub, we submodule. So anything that we think is already available in source code form, there will be a submodule. So if you do git clone and then you pull the submodules, you'll get everyone's code from every piece of malware or every piece of offensive research we've seen over the last 4 years. There's quite a lot. Time! Thank you!